Engineer Ernesto C. Prudenciado Jr., and I'm going to discuss today the limit definition of a derivative. Okay, so in your previous discussion, we already discussed about limits using algebraic function or L'Hopital's rule, but this time around I will discuss the limit using the derivative. But first, we will discuss the basic function of a derivative. Okay, so if I have here a Cartesian coordinate and I have a function, let's say this one, let's call this as function of x. Okay, so I have a point here, p1. Okay, so I'm going to solve the slope of p1. Okay, so I will draw a tangent line here. Okay, so can I get the slope of the point 1? Okay, so from our previous knowledge in analytic geometry, we need to have 2 points for us to get the slope. Okay, this is point 1 and point 2, and the formula is m is equals to uh, the distance between p1 and p2. Okay, so if this is y and this is x, okay, and y is equals to y2 minus y1, and x is equals to x2 minus x1. So substituting in the formula, this is y2 minus y1 over x2 minus x1. Okay, this is your formula for slope. So notice, class, that we need to have 2 points here for us to get a slope. So this time, in this situation, we only have 1 point because our curve or our line is a curve. So we cannot get the 2 points also within the curve. Okay, so this is now the challenge in differential calculus. How to solve the slope in P1 since we have only 1 point along function of x. Okay, so what we are going to do is to draw a point here. Let's say this is P2. Okay, so with the coordinates of x2, y2. Okay, so this also P1 has coordinates of x1 and y1. Okay, okay. So if we draw here, from point 1 to point 2, this is not the exact representation of what we are going to solve because this is a second line. So as I have said, we are going to solve a tangent line with respect to point 1. Okay, so that's a problem now. So what we are going to do is, what if P2 will go near to P1 here, so that the distance is very near that you cannot almost you cannot almost see the distance between 2 points. Okay, so let's exaggerate this part. So we will draw our exaggeration. Our P2 is very close to P1. Okay, but if we get this, if we draw a line from P1 to P2, we get the second line here. It's almost the same as the tangent line of P1. So that's the method here. Okay, so I will draw again exaggeration. Since the curve is very close to each other and it is almost a straight line, I will draw a straight line here, P1, P2. Okay, so I will call this as delta x. Okay, so I will draw the coordinates of P2 with respect to P1. Okay, so P2, x niya is x2 and the y1 is since this is f of x, the y1 is the function of x plus delta x. Okay, so this is now the y2 of p2. Okay, so p1 here is x and f of x. Okay, so we can now solve the formula of derivative with respect to the curve. Okay, so the formula now is the f prime, or the first derivative of a function x, is equals to y2 function of x plus delta x minus y1 here is fx over this distance delta x. Okay, with limit as delta x approaches to 0. Okay, this is now the general form of the definition of limit of a derivative. Okay, example. 1. Function of x is equals to 3x minus 1. So what you're going to do here is just to find values of x in the term. So let's write this first, the formula. Function of x plus delta x minus function of x over delta x. This is our general formula, right? So we will substitute this function here. So function of x is 3x plus delta x, okay, minus 1 minus, what is this here, 3x minus 1 over delta x. Okay, so simplifying, this becomes 3x plus 3 delta x minus 1 minus 3x plus 1, okay, over delta x. So this becomes, so we can cancel out both like terms here, this one also. So what we have left here is 3 delta x over delta x. Okay, so this has limit delta x approaches to 0. Okay, so this will cancel out. So what we have left here is 3. Okay, limits delta x approaches to 0. But since we don't have delta x here, so the function is equals to 3. So this is now the final answer. Okay. Okay, let's solve another example. Example number 2. So the function here is x squared plus x. Okay, so let's recall first the formula. The first derivative of the function is equals to the function x plus the delta x minus function of x over delta x. Okay, so sometimes, by the way, this is called h. Okay, so let's write another form. Plus h minus function of x over x delta or h. Okay, so this is just the same because in the other book you can find this formula for the definition of limits. Okay, so by the way, it's just the same, so no problem with that. Okay, so let's now solve substituting this function from our given. So what is our function of x? So again, no, the method here is you find x on the function, and if you can find x, you just have to add delta x or h. So let's try h. Okay, so function here is x plus h squared, no, plus x plus h. Okay, then minus function of x is x squared plus x, okay, over h. Okay, so and this is limit as h approaches to 0. Okay, so let's expound this term from binomial theorem. This becomes x squared plus 2hx plus h squared, okay, plus x plus h. So this is negative x squared minus x. Okay, so this term will cancel out. By the way, this is over h. So this term will cancel out. Okay, so any other term that will cancel out, no more. So this becomes 2hx plus h squared plus x plus h, okay, minus x. Okay, so we can still cancel this out. So we have now 2hx plus h squared plus h over h, okay, as h approaches to 0. Okay, so what we have left here is 2x plus h plus 1. Okay, so the limit here is h approaches to 0. So we will now substitute the value of h from our equation. So this becomes 0 plus 1. Okay, so the final answer here, first derivative of our function is equals to 2x plus 1. So this is the answer.